All right, day 2 of IDs. So what I want you to do is go ahead and pause the video and complete this notes on this front side. So don't go back and look at your notes. Don't go look at your cheat sheet. Don't go back and look at your notes, and see if you can go through this and remember everything. All right, so go ahead and pause the video and then come back and we'll check answers. All right, so first half, these are the reciprocal identities. We get to the Pythagorean IDs, and you might not have understood what goes on this line, but this is kind of what my thinking was. So sine squared plus cosine equals 1, and if I solve this for just sine, I move cosine to the other side, and if I solve this for just cosine, I move sine to the other side. And then our other two Pythagorean IDs, I, tan, and a second, so secant, make sure this is squared, and I sleep on a cot, Colorado Springs, Colorado. Again, it has to be squared. So remember, our Pythagorean IDs, we're always looking for everything in there is squared. So 1 squared is still 1. So everything in there is squared. Okay? All right, so let's just go back and do a little bit of warm-up. So this is kind of what we did, not kind of, this is what we did on your homework yesterday. So we're going to go through and solve this again. So what I see here is just tan and cotan and nothing is squared. So I can solve this a couple different ways. One way that I can solve this is to convert everything to sine and cosine. That's option 1. So I can do sine and cosine. Option 2 is going to be to split the fraction. And another option that I have here is switch my cotans to tans. That's another way that you can do this. So 3 different ways to do this. What I'm going to do is I'm going to do this number 2. I'm going to split the fraction. So if I split the fraction, I have tangent theta over tangent theta. And when I say split the fraction, this is a common denominator. And then I have cotan over tan. Okay, so now I know that this guy becomes a 1. And if I go in here and I look at cotan, this is the same as, let me just go in here and do this. This is the same as 1 over tangent theta over tangent theta, right? So now I'm going to go up here and do this option 3, switch to cotan to tan. So cotan is 1 over tangent, and then this is still over this original tangent. All right, so when I do this, I end up with plus 1 over tangent squared theta. Right, so when I flip this, I have 1 over tangent divided by tangent, so I multiply this and I get 1 over tangent squared. All right, well, this doesn't tell me anything. So 1 plus 1 over tangent squared doesn't tell me anything, but tangent squared is the same as cotan. So now I have 1 plus cotan squared theta. All right, so 1 plus cotan, this is my Pythagorean ID. I sleep on a cot in Colorado Springs, Colorado. Now, could have done this a lot of different ways. I could have done this sine and cosine, but this method, I just used option 2 and option 3. All right, now this one is a little more tricky. So what happens is I see cosine squared and I see no sine squared down here. So this in the denominator is not a Pythagorean ID. So, but what I do know is that I can change this cosine squared. So if I have sine squared plus cosine squared equals 1, cosine squared is the same as 1 minus sine squared over 1 minus sine. All right, now at this point, I can't just cancel this out, right? I just can't say 1 and 1 and sine and leave it as sine. That doesn't work. But what I do have right here is I have a difference of squares. If I had 1 minus x squared, we would say that this is 1 plus x, 1 minus x. If I FOIL this back out, I have 1, my middle term goes away because these are opposite signs, minus x squared. Well, that's what I have right here. So this is actually a difference of squares. So when I simplify this out, I end up with 1 plus sine theta, 1 minus sine theta, all over 1 minus sine theta. Now, let me go over this one more time, because this is a strategy that you'll have to use. if I look at this, 1 minus sine squared, I know 1 is squared. I know it because I don't write that squared there, but it is. And then sine squared is the same as x squared. If I was to factor this, difference of squares, I have 1 plus x and 1 minus x. So if I just simplify this back out, I would have 1 plus sine squared, 1 plus sine and 1 minus sine. The squared goes away because when I take a difference of squares, the square goes away. And if I use this a different way here, so x squared minus 4, this is one that's more popular. So x plus 2, x minus 2. Difference of squares, my squares went away. Okay? Now what I see is that this guy cancels with this. And what I end up with is 1 plus sine theta. Now, I know that you look at this and you're like, oh, well, wait a minute, this is more than one trig function. It's not. It's only one trig function. There are two terms, but that's going to happen sometimes. You'll see that. All right, so if I look at this right away, I see a secant squared and a 1. So what should pop in your head is I tan in a second. And if I was to move this move this 1 over and subtract it, this becomes a tangent squared. So that's one option that you might have. So one option is you use your Pythagorean ID and you convert this. So I'm just going to say option 1 is Pythagorean ID. Option 2 is going to be to split the fraction. So that's what I'm going to do. I'm going to split the fraction. So what I have here is secant squared over secant squared equals minus 1 over secant squared. All right, so this guy becomes a 1, secant squared over secant squared. 1 over secant squared becomes cosine squared. Now, I might be done. Up here, I was finished, but here I'm not. And the reason why I'm not is because I know sine squared plus cosine squared equals 1. So if I have 1 minus cosine, if I move this guy over here, I end up with sine squared. So what's the hardest part about this? The hardest part is when do I stop, right? If you see something that is not squared, then you're pretty much done. If you see something that's squared, you need to think, can I keep going? Because it's usually going to be a Pythagorean ID. Okay, last one. I've got lots of things going on here, so I'm going to use the strategy of convert everything to sine and cosine. So what I have is sine theta over cosine theta times 1 over sine theta times cosine theta, right? So tangent, cosecant is 1 over sine. This is cosine. Everything is multiplied together, so I could put it all together if I want to, but I'm going to reduce first. So sine cancels with sine, and cosine cancels with cosine, and I'm left with just 1. Now, let's just say, for example, that just as a reminder, if everything was to cancel out, it wouldn't be 0. You still have something. You still have 1. All right, so what we did up here is we simplified. And there's multiple different ways to simplify. I showed you a couple of different options or talked about a couple of different options. But today what we're going to do is we're going to go forward and we're going to prove identities. So we're going to verify the identity, and that's normally how it's going to be worded, is verify the identity. But it's a proof. That's really what we're looking at doing. Okay? So a couple of rules when we do this. So start on the, I'm going to say, ugly side of the equation, the one that has the most garbage. So if I look down here at number 1, this is the ugly side. I've got a bunch of garbage going on over here, and I want it to be 1. Okay? Sometimes when you look at this one, well, either side could be the ugly side of this one, and that's okay. So, but you do want to start on the ugly side. Okay, super important. Work only on one side. So when we do a proof, we're going to only work on one side, and at the end, this side needs to equal 1, and we're going to have 1 equals 1. So the proof is complete when both sides of the equation are exactly the same. All right? So we're going to look, first of all, for obvious substitutions and get those out of the way early. Okay? okay? When in doubt, change everything to sine and cosine, and we've talked about that before. So change everything to sine and cosine. All right, and the other thing that I'm going to put on here as another strategy is remember that when we see anything squared, I'm going to say squared. Think Pythagorean. All right, so here's what we're going to do. This is my proof. This is going to equal 1 on this side. So I'm only going to work over here. So I don't see anything squared. So my obvious thing here is going to be turning everything into sine and cosine. So I have sine x over 1 times cotangent is cosine x over sine x. And secant is 1 over cosine x. Y'all, this is required. You have to do this when you do a proof. Now, at this point, I'm going to say sine cancels with sine and cosine cancels with cosine. You don't have to go in and do each one of these individually, but you have to show me that you see sine cancels with sine, cosine cancels with cosine. And what this gives me is 1 over 1, and 1 over 1 equals 1. So here on the left side I have 1, on the right side I have 1, so I'm good. All right, this is a proof. Now, over here, I've got a couple things going on. So I can work on the left side, I can work on the right side, it doesn't really matter. I'm going to just go ahead this time and I'm going to work on just the right side. It doesn't matter, you can do this side too. All right, so what I see when I have this is that I have this 2 here, and then I have a cosine squared x. I would have the same thing on the other side. I've got this 2 that's in here. And so what I can do with this is if I pull this out, if I change this, this ID that I have right here, remember cosine squared plus sine squared equals 1. So I'm going to change this because I see sine over here. So if I see sine on the left, I've got to change this cosine to a sine. If you started on this side, you have to change it to cosine. So the only way I can do this, it's squared, luckily, is I'm going to use my Pythagorean ID. So I end up with 1 minus sine squared x minus 1. Right? So this cosine squared is replaced with 1 minus sine squared if I took this sine squared and moved it over here. All right, so now what I'm going to do is I'm going to distribute this through. So I have 2 minus 2 sine squared x minus 1. So now I have a 2 here and a negative 1 here. So when I subtract that out, I have 1 minus 2 sine squared x. Nope, I don't know why I put that parenthesis there. I don't need that. Okay, well that's what I have on this side. 1 minus 2 sine squared x. So now these are the same. So I'm done. Okay, let's keep going. So this says next time it's sometimes it's helpful to factor first. And we've seen this so far. We've seen a difference of squares. You're also going to have to do trial and error. And always the biggest one here is going to be GCF. So any of those might pop up as you do this. All right, so let's do a little practice first before we do this as an ID. So factor each of these. So this could be a difference of squares. I have 2 terms, but I have this b that's in here. So I'm going to factor out an a squared, and I have 1 minus b squared. This is a difference of squares. 1 is a square. So this becomes 1 plus b, 1 minus b. And remember, when we get rid of the square, these just become the value. So here's my final answer. All right, here's an example of trial and error. So because this is x squared, and I have a number here, this is going to be x minus 1, x minus 1. Now you could also write this as x minus 1 squared, right? This is really what we're looking for, because really what's going to end up happening, the reason why we're going to factor this is so we can cancel something out. Okay, so now let's take this concept that we have right here and look at our trial and error. I have 3 terms. This term is squared, this term is not squared, and this term is my constant. So this is the same as saying x squared minus 2x plus 1. All right, so the sine part is the whole thing that's squared. Now, I could write this as sine x squared. So the way we do this when we have something that's squared is we take the square and we move it to the sine, because that is going to be different than this, sine x squared, right? So we don't put the square on the x, we put the square on the sine, and that signifies we have this guy going on, all right? So when I have this, if I break this out, this would be x squared minus 2x plus 1. So that's like saying x equals sine. So if I look at this and I factor it, I'm going to get the same thing that I had right here. So if I factor this, I would have x minus 1, x plus 1, but then I substitute this back in and I say x equals sine, so my final answer is going to be sine x plus 1 and sine x minus 1. Now, hopefully you don't need to come over here and do this. This is an option if you're completely overwhelmed, but this is trial and error. Okay, so is this one. This is difference of squares. So remember, I'm going to rewrite this as 1 minus cosine x squared, because that's what this square is telling you. The whole thing is squared. So what I have here is a difference of squares, 1 plus cosine x, 1 minus cosine x. So this is my simplified form. All right, so using the strategy, we're going to verify the identity. Remember, verify means prove. So I want this to equal 1 at the end. Now, what I see is a cosecant and a cosecant. So I'm going to pull that out. So I'm using the same strategy that I used up here with letter A, right? I'm pulling out a GCF. So when I pull that out, cosecant squared x, I'm left with 1 minus cosine squared x. All right, so now what happens is, remember, I need all of this to equal 1. So I'm just going to keep this guy right now because I'm not sure what's going on with cosecant here. And then this becomes my Pythagorean ID. So sine squared plus cosine squared equals 1, right? So if I move the cosine over, I'm left with just sine. So this is going to get simplified with sine squared x. So sine squared plus cosine squared equals 1. I move the cosine over, and here's what I have. Now, I know cosecant is the inverse. So I have sine squared x. Hold on. That's this. Sine squared x over 1 over sine squared x. And that's my cosecant. Sorry, my order's backwards here. All right, so now I have sine squared over sine squared, so this cancels with this, and I'm left with 1 equals 1. All right, so perfect example of using a greatest common factor, and then from the greatest common factor, I went in here and used Pythagorean ID. So we don't have to do this, but first thing I did was a GCF, and then I used my Pythagorean ID. Now, another thing that you could have done is you could have set that this was 1 plus cosine x, 1 minus cosine x. So I could have gone in and done that too. So there's more than one way to do that. This is just what I think is the simple way. All right, so let's go down here. Sometimes it's helpful to get rid of parentheses by multiplying this out. So I'm going to say by foiling or distributing. And when we FOIL or distribute, really what we're doing is we're multiplying. So if I look at this, I have sine minus x, sine plus x. So you see that these are opposite. And so when I have this, I could FOIL this whole thing out, but we know the middle term is going to fall out because one's positive and one's negative. So what I end up with is sine squared x minus cosine squared x. Okay, where would I go next? Well, that is a tricky subject. So remember, my Pythagorean ID is sine squared plus cosine squared equals 1. So this is not plus. So this is not my Pythagorean ID. So this does not simplify to 1. I could go in here and I could change this around. And I could say, all right, if I change my sign, this would be 1 minus cosine squared x minus cosine squared x. And now I have 2 of these, so 1 minus 2 cosine squared x. So this is an okay answer. This is an okay answer. Or I could have gone in and changed this one. So where do we stop? Well, sometimes we don't know where we stop. But at this point, I would have probably stopped back here. Because this is not a Pythagorean ID, I could have converted this. Now, hear me on this. The only reason I knew that is because this is not any more simplified than this. So what you're going to have to do is just keep practicing these, and that's going to make it easier to determine, okay, it's time to stop. All right, so what do I have here? So this is squared. So if it's squared, it's the same as saying tan theta plus 1, tan theta plus 1. I have 2 of those. If I have 2 of these and I FOIL it, I end up with tan squared theta plus 2 tan theta plus 1. And in this case, there's nothing that I can do to simplify this, right? This is my simplified form. This is really my expanded form. Oh, that was it. Okay, I guess we've got just a lot of practice in the homework.